Welcome back to the final exam review. This is part 2. We're going to go back to type 1 and type 2 error. So we're going to look at this chart at the bottom of the page here. What is true? Well, either H0 is true or the alternative is true. And then we're going to see what we did. So if you do not reject H0 when it was true, you didn't do anything wrong. But if you do not reject H0 when the alternative was true, you made an error, and we call that a type 2 error. If you reject H0 when in fact it was true, that's a type 1 error. And in fact, as we're going to find out in a couple of minutes, that the probability of making that type 1 error is what we call alpha, or our significance level. Now if we reject H0 when the alternative was true, then we did great. That's exactly what we wanted to do. So as I said, the level of significance, which we denote by alpha, is the probability of making a type 1 error. Now we need to know you guys need to know how to interpret a confidence interval. You need to understand how to calculate a p-value and to understand what the p-value is. When we do a test of significance, we get a test statistic. From that test statistic, we get a p-value. The p-value is basically the probability of making a type 1 error based on your sample. Or another way to think about it, or another way to look at it, it's the probability computed, supposing that the null hypothesis is true, that the test statistic will take a value at least as extreme as that actually observed in your sample. So once you get your p-value, basically what it's going to tell you is my test statistic in a place where it should be. If I've got a normal distribution, most of the data lies close to the mean. If it's too far out in the tail end, imagine a sample of size 50 or 60, that the mean of that sample would be far out into the tail ends of a probability distribution. It would be considered unusual. So in a hypothesis test, that gives us enough evidence to reject our null hypothesis distribution and to go with what the alternative is saying. Now, and so what we use in our class as a benchmark is the p-value is less than alpha. That's when we're going to reject the null hypothesis. We're going to have a level of significance that we're willing to deal with. In other words, a level of the probability of making a mistake. We're going to say, I just don't want to make a mistake more than 5% of the time. But if my data shows me that I'm going to make a mistake more than 5% of the time, then I'm not comfortable rejecting the null hypothesis. But if my sample shows me that I'll make a mistake even less, that's pretty cool, then I'll feel comfortable with rejecting the null hypothesis in favor of the alternative. And then learning how to interpret these in context of the problem. And also looking at a hypothesis test and knowing what error you made. If after you've made your conclusion, then somehow you find out the true value of mu if you made an error or not, and if you did make an error, what the error would be called. Now the types of problem that you're actually going to see on the test, as well as knowing these definitions and understanding them so you can work with them, is the problems that you're going to see. Well, you're going to have to read and interpret graphs. In other words, getting data off of a graph, which is something you really need to know how to do. Make sure you read the label so that you know the units, or whether the graph is in frequency, which are the counts, or relative frequencies, percents, ratios, probabilities. You'll also need to know how to calculate measures of center, the mean and the median. Calculating measures of spread, you'll have to be able to calculate the range. Now, you'll not have to calculate the standard deviation from a sample, but you must understand what that standard deviation means. Being the average distance each data value is from the mean, it tells us something about the spread. The only standard deviation you are responsible for in this class is for the binomial distribution, which is the square root of n times p times 1 minus p, but we'll get to that in a minute. You'll also have to know how to calculate the interquartile range, which is your third quartile minus your first quartile. So in other words, you need to know how to calculate the first and third quartile. The second quartile is just your median. You'll have to know how to talk about the shape of the distribution, whether it's left skewed, right skewed, it looks uniform or normal. And also with the shape of the distribution and its effect on the mean and median, or its effect on what measures we should use. If I have a highly skewed data set, I don't want to use mean and standard deviation. The better way to calculate measures of center and spread would be to do the median and the interquartile range. Also remembering that outliers greatly affect the mean and the standard deviation. So again, the median and interquartile range is a better measure of center and spread. So knowing these things, and knowing that if I have a right skewed data set, my mean is going to be greater than my median. The mean follows the skewness. So if I've got something that's left skewed, it's going toward smaller numbers, my mean is going to be less than my median, knowing those type of answers. Remembering, and in the same vein, is that's why we say that the median and interquartile range are resistant to outliers, because that pool, it doesn't affect the median and interquartile range as much, very little in some cases. So also knowing how to read a box plot, and that the box plot is a 5-number summary. And what is that 5-number summary? Well, the 5-number summary is just the minimum value in my data set, the first quartile, second, third, and then the maximum value. But remember, when you're finding quartiles in these measures of location, basically, you better make sure that you put that data set in order from smallest to largest. So be careful on the final. You might get a data set that is not in order. Please make sure you put it in order, or you'll get the wrong quartiles and get the wrong answer. So please make sure you remember to do that. You'll have to know how to work with the binomial distribution. You'll have to calculate its mean and standard deviation. Remember, the mean is just, the mean is just n times p, and the standard deviation is, which you see sigma, is the square root of n times p times 1 minus p. So you'll have to do those calculations relatively easy. You'll have to know how to find the probabilities using the CDF, the cumulative distribution function output from Minitab. You have test 2 to help you, and lots of problems that we had done. Knowing how to calculate probabilities from a normal distribution, knowing how to use Table A and the standard normal distribution. In other words, we could standardize any normal random variable by the calculation Z equal x minus mu over sigma. Z is just how many standard deviations our data value is in its distribution. Now, if we need to unstandardize any normal random variable, we just do some algebraic manipulation to our standardization formula, and it would be finding our x values just to add the mean to sigma times z. How many standard deviations you're out times what a standard deviation is, and then add that to your mean. Sampling distributions, knowing how to work with sampling distributions and what they are. So let's look at the sampling distribution of the sample mean of a specific sample size, n.